Hello, today I'm going to show you how to get the derivative of cosec inverse x dx. So the first thing you do, you equate cosec inverse of x to y. Then we multiply both sides by cosec. Cosec and cosec inverse will cancel out, so you'll remain with, then we're going to get the derivative on both sides, remembering that cosec y is the same as 1 over sine y. So we'll get the derivative of cosec y with respect to dx, since our question was with respect to dx, and we'll do the same for this other side. Well, basically the reason as to why we did all this was to, this part was to eliminate the root to the power of -1. Then from there, we know that cosec y is 1 over sine y. So, so the derivative of 1 all over sine y with respect to dx equals 1. Then at this point, we're going to introduce the quotient rule. And the quotient rule states that the derivative, let me just use a different ink, dx equals v du over dx minus the difference with product rule, u dv over dx all over v squared, where in our case u is 1 and v is sine y. With the rule with us, then we're going to just implement it. So the derivative of 1 over sine y with respect to dx equals v, which is sine y. The derivative of a constant is 0, making this whole part 0, minus u, which is 1, dv. The derivative of sine y is cos y dy over dx. Do not forget the v squared, which is sine squared y. Then from here, we obtain that our answer, the derivative of 1 over sine y with respect to dx equals negative cos y dy over dx all over sine squared y. And we know that sine squared y is simply sine y dot sine y. So placing this in our equation, we get negative cos y dy over dx all over sine y all over sine y. Cos y all over sine y equals cot y. So negative cot y all over sine y dy over dx, and this is the derivative of 1 over sine y with respect to dx. From this point, we're going to introduce a right angle triangle so that we can bring our equation or our answer not in the y form but in the x form. So when we draw a triangle, letting this angle be y, and remembering that cosec y was equals to x, and cosec y was the same as 1 over sine y, so we can just say 1 over sine y equals x. So sine y, if 1 over sine y equals x, then sine y is just 1 over x. And from the identity SOHCAHTOA, sine is opposite hypotenuse. So the opposite is 1, the hypotenuse is x. And using Pythagoras theorem, we know that the base will be the square root of the hypotenuse squared minus the square of the height. So that we can be able to get cot y and sine y, cot y is just the same as 1 over tan y. So to obtain To obtain cot y, let's first start with tan y. Tan y is opposite, adjacent 1. So if tan y equals 1 all over the square root of x squared minus 1, then our cot y, just getting it from here, will be just the inverse. So our cot y will equal the square root of x squared minus 1. What else is in our answer? You're also looking for sin y, and sin y will be opposite, which is 1 all over hypotenuse, which is x, and we already had that. So our answer then, the derivative of 1 all over sin y all over dx is equals to negative cot y, which is the square root of x squared minus 1, sin y, which is 1 over x, which will just be x 1, dy over dx. Remember as well where we got this from. We got it from here. The derivative of 1 over sin y over dx is equals to 1 from this point. So we're just going to equate our equation, what we've already obtained right now, this to 1, so that we can be able to get our answer, which is we get dy over dx of this. So if we equate this part to 1, so negative x, the square root of x squared minus 1 all over 1 dy over dx, then we equate it to 1. We'll just, to make dy over dx associated with the formula, we'll just multiply with the reciprocal of this to obtain dy over dx equals negative 1 all over x, the square root of x squared minus 1. Thanks for watching my video.